Hello, everyone. Welcome to the NCHRP 2044-39 implementation of Guidebook for Managing Data from Engineering Technologies webinar. My name is Said Anaf Morshed, and I'll help facilitate today's webinar. In this webinar, transportation agencies participating in the NCHRP 2044-39 project will share details of the implementation projects, including successes, challenges, and lessons learned for queer agencies. As a quick reminder, at National Operations Center of Excellence, we offer a variety of resources to support the transportation systems management and operations community. You can go to NOCO's website to browse through links for TISMO resources and news. Previous webinar recordings and case studies can be accessed from here. Now, I will cover a few logistics for today's webinar. We are recording this webinar and the recording will be available on NOCO's website. All the attendees are encouraged to stay engaged by using the Q&A feature for questions and chat feature for comments. These are both on the bottom of your screen. We have a question and answer session at the end of the presentation. So if you have any questions, we encourage you to enter them in the Q&A area as they come to your mind at any time. Also, please feel free to enter your name and agency in the chat to say hello to your peers. Now I will hand it over to Kelly, the Senior Director of Transportation at AEM, for today's webinar's moderator. Thank you.
Thank you. Okay, I'm going to share my screen. Does that look good?
Yeah.
Okay, so hello everyone. My name is Kelly Claver-Pasha. I'm a Senior Director at AEM Corporation, and I was the principal investigator for this project as well as the original project, which I'm going to provide a little bit of background on today. But first, we're going to start with a quick poll question just to see who we have in the audience. So just quickly, what type of organization do you represent? I'll give everybody a few seconds to click the appropriate response. Okay. Anaf, can you show the results, please? Okay. So we have a mix here with mostly, I think, looks like state and regional government agencies. Great, thank you. Okay, so I'm going to start with a little bit of background to this project and the webinar that we are going to, the presenters that we're going to hear in the webinar today. So just a quick background, we all know that increases in connectivity between vehicles, sensors, systems, shared use transportation, and mobile devices are resulting in unexpected and unprecedented amounts of data that are being added to the transportation domain at a very rapid rate, and that these data from these emerging technologies is offering a lot of potential to uncover insights to help drive better decision making throughout all levels of transportation agencies. We're all also aware that the volume, speed, and granularity of these data are unprecedented and present challenges in data management for many agencies. So back in 2018, NCHRP 08116, which was titled Framework for Managing Data from Emerging Transportation Technologies to Support Decision-Making, was conducted to try to address both these opportunities that these data provide, as well as some of the challenges. The outputs of that NCHRP 08116 project, the primary output was Research Report 952, It was published in 2020, and it's a guidebook. It provides a modern big data management framework that includes new concepts and methodologies, best practices, and over 100 recommendations for managing data in a modern, flexible, scalable, and sustainable way. It also lays out a roadmap for agencies on how they can begin to kind of from the bottom up, begin to shift technically, institutionally, and culturally towards more effectively managing and handling these emerging technology data. And it provides some examples and references of transportation agencies that at the time when the research was conducted were exploring or already navigating the implementation of some of these more modern data management practices, including some of the challenges that they had had and their successes. And when we finished the project, the panel realized that there was a lot of good information, but it was also very, very dense, and that this project might benefit from an implementation project. So in TRB or NCHRP program has an implementation program, which is the 2044 program that tries to take research outputs and move them into practice. So the panel applied for an implementation project for that 08116 project. And the objectives and approach for that project is to conduct training and provide technical assistance to help bring the recommendations, the roadmap, and some of the tools that are presented in the 952 report to DOTs that were interested in better managing data from emerging technologies, as well as driving the benefits from these data. So we started out by identifying agencies. We had up to 4 agency participants, and developing and conducting a 1.5-day training workshop with each of the participating agencies that was based on the contents of the 952 report. And then each of the agencies identified and conducted a pilot implementation project using the concepts from the guidebook and the training workshop. And the timeline was we did the trainings between December 2021 and April 2022. The agencies primarily focused on conducting their implementation projects during calendar year 2022, and I think are still kind of working on those to date. We conducted a peer exchange among the participating agencies to share their accomplishments, some of the challenges and lessons learned back in February, and then this national webinar to share the outcomes with a wider audience. So that brings us to where we are to date on this project. So today and the rest of the webinar, you will be hearing presentations from the 4 participating agencies, which is the Arizona Department of Transportation, the District Department of Transportation, the Florida Department of Transportation, and the Rhode Island Department of Transportation. So before I hand it off to our first speaker, let's put up the second poll question, please. So a question to the audience: what type of emerging technology data does your organization actively use? And you can select all that apply here. So which data are you either collecting or maybe purchasing and actively using in your organization? We'll give it just a few more seconds. Okay, Anaf, can you please show the results? So probe vehicle data, 44%. Connected vehicle data, 25%. And then we have 1 using mobile navigation, app data, 1 using social media, video, and other. Thank you. And then let's also look at poll question number 3. So just a slight twist on this one. What type of emerging technology data would your agency like to be able to make more use of or better use of? Pretty much the same responses, but maybe there are some that you would like to use that you currently are not, or some that you would like to be making better or more effective use of. A few more seconds. Okay, let's close the poll and look at the results. Okay, so a few more there. Like maybe a few more for connected vehicle data. Thank you. Okay, so I'm going to stop sharing and introduce our first speakers here. So our first speakers are from the Rhode Island Department of Transportation. We have Russell Holt. Russ is a principal civil engineer with RIDOT, assigned to the TMC in Providence. Since working at RIDOT in 2003, Russ has designed, implemented, managed, and advised on various traffic engineering, operations, safety, and TSMO-focused projects and efforts. His experience ranges from street-level retiming of traffic signals to authoring or overseeing state-level policies and plans, such as RIDOT's work zone safety and mobility policy in 2008 and the TSMO performance management plan in 2016. Prior to joining RIDOT, Russ worked as a research assistant at Virginia DOT Smart Travel Laboratory. He graduated from Clarkson University in 2001 and the University of Virginia in 2003. And Russ will be joined today in the presentation with by Steve Cutt. Steve is a data analyst with RIDOT within the Asset Information Systems Unit. He started work at RIDOT in 1992, and during this time, he has led the implementation and support of several GIS and IT projects related to ITS safety management, planning, maintenance, and operations. Steve graduated from the University of Rhode Island with a degree in landscape architecture. So Russ and Steve, the floor is yours.
Okay, thanks so much, Kelly. I appreciate that. I'm going to attempt to share my screen and hopefully this works well. If and when you can see the presentation, please let me know.
Looks good.
Okay. All right, great. So I appreciate everyone being here today. We're going to talk, excuse me, I'm the one from Massachusetts, so I'm going to talk fast. I hope that's okay. But we don't have much time to speak, so we're going to give a high overview of what we've done so far with the guidebook, which is great. So early stage experiences from RIDOT, we're going to touch on. First off, kind of the business case. Why would RIDOT use the guidebook, or why are we using it? So for us, there's really two big reasons. And Kelly did a good job covering it at the beginning. There's so much data that's out there now, and more is coming. A lot of it's unknown where it's going to come from. Just the size of the data, the veracity of the data, all that stuff. It's just it's so much that my agency tend to be a smaller agency compared to most state DOTs, but we're still a bona fide agency. We've got 700 employees, 1,100 lane miles, 1,000 bridges or so, 700 signals, urban areas, big freeways. So TSMO is key to us. I know this is an OCO webinar. So TSMO, the amount of data, the types of data that are coming out of ITS and TSMO type equipment is just, to me, it's mind-boggling. I'm a civil engineer, not a data guy, but it's mind-boggling. And to date, RIDOT has done some things with, say, crowdsourced data, right? Like Waze data, the travel time messages you see on the sign right there in that image, those are from Waze data, ironically enough, because at the time we weren't buying probe data. So that was free to us. But long story short, why the big data? Why use the guidebook? Because we really haven't done much with, or really anything with cloud-based data and support. It's been all on-prem type systems, traditional systems. And reason two is basically state level adaption from on-prem to cloud data is still fairly early for us. We're behind some states. We're maybe ahead of a few, but we don't have like a governor's decree or a massive initiative, right, to make everything in the cloud. I'm guessing it's like a lot of states out there. We're kind of in the transition period, and we're still early on. So we saw value in this guidebook. This slide just highlights that roadmap that Kelly mentioned. Kelly and your team who drafted this whole report up and did all the effort, I say thank you, because we're a smaller DOT again, and I found the roadmap very helpful. Chapter 3 has the steps of the roadmap. You can see them here. And I wanted to show this here because it helped me illustrate how far RIDOT has gotten. The green steps 1 through 3 up to securing buy-in, as Steve Cutt's going to talk about in a minute, we've done well on those and we finished those. However, when it comes to step 4, that's kind of where that's where we've got to date. And we had some challenges along the way. So we still have a ways to go to finish our effort here. The other states talking later today are going to talk, you'll see, I think they're all beyond where we've gotten. But we still have some valuable input to share, and I appreciate you listening. So basically, overview and the objectives of our pilot. So first, establish the environment in the cloud. Of course, we just talked about it. The on-prem has certain limitations. And again, Kelly, the guidebook has, I think it's figure 3 or figure 2, that chart that shows, or an illustration that shows traditional ways of handling big data, and then the cloud-based way to do it. Meaning you don't transform data before you put it somewhere and let people have access to it, right? That type of stuff was eye-opening to some of us here, including me. And we want to have flexibility and scalability with the data, get the most value out of it, as I mentioned. So that's really a big objective of this, and to take those first steps in the cloud. The third green bullet there is integrate with existing enterprise GIS. Steve's going to talk about his expertise in his realm is the GIS world and data. It's exciting for me when I learned that his office is kind of like the TMC and TSMO folks here. They've also see a big push or a reason or initiative to, make this an initiative, right? To start going to the cloud, because it's just not, how much longer are we going to be able to use on-prem things to be nimble enough and archive stuff and pay for stuff and support stuff. Anyway, so there's probably some data experts here. When I say nimble, you might say, well, wait a minute, having it on-prem is more nimble, right? Well, there's a lot of detail there. I know it's interesting, but we really, our GIS folks really think that they could see the value in the doing more for big data and doing it the right way. So they were on board. The main kind of a big objective for us was to have that first plan. We had no other separate plan that I'm aware of, Steve, that talked about what we want to do with this, how we want to do it. So an implementation plan was developed. Kelly, I thank you very much for helping us with this, to help us talk about what are our big data sources we have, what are we going to do with it, and then to help us set the groundwork for the stewardship of the data and the governance of the data, which is key. Again, this is all kind of new to us here in Rhode Island, or Rhode Island DOT. And finally, learn, iterate, and follow through, obviously. TMC, as I said, we decided to be the guinea pig. I'm biased. I'm a champion for TSMO and operations, right, at our DOT. We have the other folks who are more traditional, roads and bridges, and it's all important. We have to work together. But we decided that our TMC would be the guinea pig to show some things. I'm going to talk about that a little bit more later. And now I'm going to transfer to Steve to talk about our approach. Steve, please.
Great, thank you, Russ. As Russ mentioned, we never got to the point of actually implementing any workflows or systems, but working with Kelly and her team through the process, it was great kind of discovering where RIDOT was and taking a closer look at how we felt we needed to move forward as a team and as an organization to achieve what we had set forth in the project. So it became clear early on that with the current infrastructure that we had and the resources that we had in place, that we were going to need to obtain assistance in doing this. As we were going through this process, we also realized that there were benefits to including this as part of our enterprise GIS infrastructure. As Russ had mentioned, we've worked on various different projects and initiatives over the years in support of ITS and TMC, but all the systems tend to kind of work in isolation, although we've made progress over the last several years in integrating many of those sources. So in obtaining a third-party vendor, the other outcome we wanted was really to get a sense of cost, right? Billing and usage and performance. And while we were getting that from our state IT, we felt this was a good opportunity to start looking at a shift from an on-prem to the cloud. Early on, we had our TMC involved with Russ and his team. our office, which includes several data analysts, database administrators, GIS staff. And then we made the decision early on to bring state IT to the table and participate through these workshops that Kelly and her team were putting on for RIDOT, which, as it turned out, was a critical point in ensuring that we had their understanding of where we're heading. So that close coordination with state IT was critical. Ultimately, we've made that decision where GIS currently is within the planning section here at DOT. With this next step in this initiative, we plan on moving GIS and the big data into mainstream IT. So as Russ mentioned, all of our systems that we have for GIS are on-prem. We were at a critical state of needing to go through a major upgrade of that infrastructure, and we started through this project. And that's when, through the review of our existing system, we determined the best thing to do was to bring this project and the big data within this environment. And as Russ mentioned, the on-prem just lacked the ability to store large amounts of data, which we over the past have had that as an obstacle for implementing any of these integrations. So the proposed architecture, which we work in close collaboration with our vendor ESRI, is being used during the development of our plan, and ultimately will be used and has been used through the solicitation process for a hosting vendor. The data lake was included in the overall architecture for GIS, since the GIS section had already been leveraging data streams from Waze and vehicle tracking.
Okay, thanks so much, Steve. I am going to talk about so what about the actual pilot, the data and the tools and tech we would use for this? Well, we decided to use the INRIX live feed via their API in the TMC. RIDOT has had access to that feed since in 2018, we got it back. We had it years ago and then we lost it. We weren't able to make the case to fund that. So that's a probe data source, obviously most people here know, but we decided to use that. Why? Probably, sorry, I know the main reason was the size. So the estimates I have are maybe up to 10 gig a year, 10 gig a day for Rhode Island, the networks that we have coverage for INRIX. And per year, that's maybe 2 terabytes or more of data. I think that's on a 2-minute resolution if we went with that. So anyways, we're talking about big data, right? Terabytes of data per year. It's something that our TMC's never been able to, we've tried, to archive some of it, and then how would we use it and have access to it? It's just, it almost pleads to, to use the cloud for such things. So we decided to use the INRIX feed. It's a big nation, but it's a small nation. We try to keep tabs on what other agencies are doing, and the other folks coming up in a minute here, they're doing amazing things with data and getting the message out to travelers on travel information and safety and all that. So we do some cool things too, but we just try to learn from others. And we know that the say incident detection, for example, we use the INRIX data on a non-cloud based. We downloaded the data and then used it, looked at some historical archived INRIX data, came up with a kind of rudimentary algorithm for incident detection. And we integrated that into our current software. It's not an ATMS, it's called Roadways. It's really incident management tracking software. At the bottom right, you can see it. We did take pilot steps to do this. This was via EDC 6 and a stick grant in 2001, I believe, 2022. We took some steps on this. This is around the time when I got to know you, Kelly. Somehow we crossed paths and you said, hey, would you like to be a pilot implementation state? So in any case, we were doing this effort on our own. And but the key is everything you see there on the screen, none of it was in the cloud, right? It was all, let's call it traditional. We download the data, save it somewhere locally on a hard drive, and then have a consultant run the analysis, develop the algorithm, and try to integrate it. So this was everything you see on the screen. That was just one corridor, I-195 in Providence, and that was it. We didn't have the resources to do it statewide. which would make sense. So there's that. And then also the data will be used and trialed in other applications. This is just an example application that we plan to use this effort to show, use the data lake and show the value to DOT on using the cloud. So that's that. And then Steve, I think you'll talk about the major challenges so far, please.
Sure. Thanks, Russ. So major challenges so far really have all been non-technical, right? We've kind of set the vision. We understand where we need to go, and we've got the business case for what we need to do. However, we've been working through the process to really get IT on board and ensure that we have a path forward that we can truly implement the system that we envisioned. So the decision early on to get IT on board, while this has, added overhead to the project schedule, we feel this has benefited us to ensure that we've taken an approved approach. Going through a process, there had been turnover with our state IT, and we had to go through a couple iterations of working with that team to determine whether we would use the state AWS tenant or we would go to a third party. As we worked through this process, it became really clear that the way the current state system was for supporting a cloud migration was not meant for a large system as we were proposing. So the governance process wasn't modernized for cloud projects, and essentially that nimble environment that Russ had mentioned, we felt that if we had made the step to work within the state AWS environment, we wouldn't have that flexibility because of the highly governed nature of the environment. So we agreed with state IT that the best path forward was to go out to RFP. We went through a solicitation to work off an MPA and did not receive the adequate results. However, we felt that if we made the move to a third-party cloud and the state has changed, we could determine whether or not we would move that back into the state AWS environment.
Sorry, Steve, I jumped the gun on that slide.
Yeah, no, that's okay. So yeah, so what we've accomplished so far is, as Russ mentioned, we've established an implementation plan for big data and the pilot, which has allowed us to get that executive support and state IT support, because there's a clear understanding of where we're going and how we feel we need to get there. It's allowed us to secure the funding for the next 3 years, so we know once we go through this process that it'll be an environment that we'll be able to support for a minimum for the next 3 years, and that includes both the hosting and the licensing for the environment. And then ultimately, as I had mentioned, we tried to do an MPA approach that did not work out because we didn't receive the adequate responses. So we've more recently decided to go out to an RFP, and we're expecting to have a vendor on board by October of this year.
And with that, Steve, thanks. That's what we had for our presentation today. Thanks for listening.
Thank you, Russ. Thank you, Steve. If anyone has any questions for Russ and Steve, if you could just put them in the Q&A at the bottom, and we're going to come back. We're going to make sure that everybody has an opportunity to give their presentations, and we should have enough time at the end to start to go through some of the questions and provide answers. So go ahead and just type those in, and we'll come back to those at after everybody has presented. So now we have another poll question. So what are your primary challenges with respect to managing and making use of emerging data? There's quite a few things there. Because it's a single choice. So what is your primary, your biggest challenge that you see in being able to manage and make use of these emerging data? A few more seconds here. Okay. Enough, can you please share the results? So it looks like the most is staff skill sets, 38%. Data procurement and cost, 25%. Traditional database management systems and disparate systems, 19%, and breaking down data silos and data sharing. So thank you for that input. So we're going to move on to our next presenter. So Jeremy Delmore is going to be presenting for Florida DOT. Jeremy is the Transportation Systems Management and Operation Engineer for FDOT District 5. In this position, he is responsible for leading FDOT's technology efforts for Central Florida, including working in the fields of signal timing optimization, managed lanes, simulation modeling, data management, and connected and autonomous vehicles. So Jeremy, feel free to share your screen.
If you'll bear with me for 1 second, I did not like the way that that shared. We will go ahead and share this just a little bit differently. Almost there. Sorry about this, guys. And share screen. Hopefully that looks a little bit better. All right. Thank you, Kelly. Appreciate the opportunity to go ahead and talk to you guys today. Go ahead and take a look at the project that was chosen here for the state of Florida. So I am with District 5. As a district, we already went ahead and kind of operate a little bit like independent units, work together.
Jeremy, sorry to interrupt.
Yeah, go ahead.
You're not sharing your screen yet.
Oh, I am so sorry. Is it now sharing? Can you see it now? Awesome. Okay, sorry. I'll go back to the introductory slide. And what we're trying to take a look at here is the overview of the pilot project, the activity that we took underway. It sounds a lot like the work that RIDOT was doing, in which we have something we refer to as the RTMC map. This uses probe vehicle data. So our data source is not INRIX. In this case, it's actually here. And what we're looking at is speed variations versus historical. And I'll go into what those calculations actually look like. And based on the percent deviation, it's an indicator of the probability that there's a likelihood of something that's unusual that's going on in that particular location. It focuses our operators' attention. We use this primarily on arterial roadways. The reason for that is that it is, in the state of Florida, we have a very mature freeway deployment. We have 100% of our limited access facilities covered. And on the arterial side, we have a more limited program. We don't have it quite built out as much. So we're looking to go ahead and be able to use some of these emerging data sets in order to help us to more actively manage our arterial systems. What this does is this gives us insight if there's something anomalous happening. Then we can go ahead and interrogate our other systems to look at equipment failures, potentially construction impacts or crashes. So this is a system that was up and running on premises in FDOT District 5. And we were looking at how we could be able to make this into a statewide application. So here in District 5, like I mentioned, we had an on-premises, not a cloud-based system. So over on the right is actually a diagram that kind of shows the overall structure, where we went ahead and had Elastic as where we were reading things into. That went ahead and also put things into cold storage into Hadoop. We then had APIs by which we could access that data in order to be able to push it into a set of SQL tables that can be hosted on a GIS server. So that was all running on premises on Big Iron here in the district. And those visualizations were great for us, but it made transferring this to be a statewide practice much, much more difficult. So when we looked at the opportunity here in implementing the guidebook, it was about how do we take these kind of on-premises local solutions that each one of the districts kind of comes up with and look at how we can instead get more value for the state as a whole. How can we put this into an environment where things can be shared? And when we look at innovations and new insights into data, we thought it was really beneficial that others would gain the benefit from it without having to try to share code bases, deal with it, our different operating environments, so a little bit different each other. So when we started looking at it, our application, the guidebook, was that we were trying to go ahead and meet with decision makers in other districts to make sure that they were on board with the same concept of us going to cloud-based systems, obtain their buy-in, agree to the use case, and then to go ahead and meet with technical staff and make sure at the technical staff level that there was buy-in from them, that they understood kind of what was going on, that they agreed that the deployment of this makes sense. We then were developing a shared space in AWS, which is the cloud system provider that we ended up landing on, and then being able to provide access, get the system up and running, and basically try to demonstrate good value back, and then to keep iterating, similar to the steps that you see on the right in terms of how we applied it. So if we look at our existing condition, what we had in place was, as you see, everything is on premises. There was a set of nested data coming from the Here cloud that was a set of kind of linked node data, but it was heavily nested. So we had to go ahead and run it through a processing server in order to go ahead and de-nest that information and then read it into Elastic. Elastic, we would then pull out of a set of APIs. Those APIs went ahead and also handled the calculation of historical percent, as well as what the existing percentage is for each one of the link segments. That was read into an NS2ID link node based basically database that then went ahead and displayed on a GIS interface. So when we start looking at what went on with this, is that the calculation of that historical information was based on 15-minute periods, and it was specific to not only the segment in question, but also to the day of week. And we only used 2 weeks worth of data. So we really try to focus in order to be able to capture any kind of seasonal changes or changes that happen based upon new construction activities to be able to quickly adapt. When we looked at what we were migrating over to, we were basically taking the processing server as well as kind of the intermediate database that it sits in, and then be able to pull information out of that database and push that up into the cloud. Now, we did a little bit of change in technology. I really don't think that's hugely germane here to move over from ES over into Mongo. But really what we were looking at doing is by pushing that up into the cloud, we would be able to share that practice without actually having to look at new installs. So we had some expected challenges going into this. We were expecting is that there were going to be a lot of institutional barriers surrounding cybersecurity, user management. Keep in mind, we're used to running as individual kind of entities as districts where we manage our individual users. We're responsible for individual cybersecurity. So in trying to share something across districts, we thought that that would be, a big issue. It turned out that we were able to overcome those relatively easily. Where we ran into actual barriers had to do with, there was a lot of concurrent development. As you heard from the folks in RIDOT, there is some guidance in the state of Florida for us to be cloud first, for us to look at going to the cloud. So that type of deployment makes sense for us to be able to migrate to and to get support of technical staff. What we run into problems with is that in the migration, there becomes a question of when do you move what systems when, and then how do they work together? What you don't want to end up with is too many clouds, and at the same time, there's a issue of how do you coordinate your activities amongst one another. That tended to actually be a bit of a challenge, and I'll go into a little bit more of that. When we start looking at multiple clouds, we did know that there were 2 different systems that were already set up for the state of Florida. One was our information technology group, the folks that run my email account. They run in an Azure environment versus on the traffic management side, what we do in TSM&O. We're actually separate from that system, and we run everything in AWS. So we had to kind of discuss with both those groups in order to understand what the right direction was to move forward. The other thing that we ran into as a barrier was that we were stuck kind of in an on-premises mindset. That's how we know how to do things. That's how we've done them for years. And whereas we have a desire to go to cloud, it's hard to look at your historical documentation to understand the steps that you need to take and to make sure that you start to make that shift and you realize just how much that permeates all the things that you do. So whereas our migration seems relatively simple, of it, we had a few things that were running on premises, they were just moving up into the cloud. There were a few sticking points that more had to do with adjusting our mindset. So as we were going through these steps, what we went ahead and looked at was how are we going to move our system over. As I mentioned, there were two separate contracts that were going on at the same time. There was the overall state moving all of traffic management into the cloud. And we were trying to piggyback off of that work. At first, very robust data lake. It goes ahead and has all of the functionality that you would expect. With us reading and hear data and then just presenting that system, it is what we refer to as an informed system. It doesn't do any command and control. So it doesn't tell our traffic signals what to do. It doesn't update our dynamic message signs. When we looked at the more robust system, it was actually going ahead and going to have command and control with it as well. So that had a lot of needs and complexities that were faced around it. And there was a concern about making sure that we weren't crossing the streams between our two contractors that were trying to go ahead and move through it. So what we went ahead and came down to was the ability to say, let's be on a common system. Let's be in the same region. So we went ahead and invested in AWS, and we went ahead and were able to work out a solution where we would also be hosted in the Ohio region. And then from that, what we went ahead and did was we built up a parallel system for the time being. And then we're able to go ahead and show value with that work, which is consistent with the guidebooks kind of demonstrating value quickly. And then from there, we were actually able to use that in order to build support for the larger, more robust data lake that was under construction. So the agreement on the fork really was what kind of set us free. With that, there was just constant communication that was going on, trying to go ahead and make sure we're agreeing on what the fork looked like, understanding what the design documentation for the eventual migration would look like, and then looking at the platform and making sure that we were all on the same page. Once we got through those hurdles, the actual implementation of moving from on-premises to cloud was relatively straightforward. So again, the value prop to it was it does build support within the agency that this is something we can be successful on. One of the things that we also realized was that when I mentioned that we were stuck in an on-premises mindset, we did not previously go ahead and reflect in our documentation of how we're managing data about whether things were on premises or on cloud, because it was just default, everything's on premises. So when we started trying to provide direction to our contractor to move services, what we found was we provided inadequate detection or direction on when we say that, what it actually means that needed to move. So we have now gone ahead and updated a lot of our Visio documentation to go ahead and include what servers things actually physically run on, if they're local, or what AWS instance, what the location is for that virtually, in order to be able to make sure that we understand where sources are happening, where processing services are happening, where storage is, so that each one of those is clearly understood. That helps us to be able to understand how migration is going to affect one system versus another. Since then, we've continued to develop. This was what I mentioned previously, was what, as Kelly talked about when we got together in February, where we were. Since then, we've been adding some contextual data to our existing RTMC map. So this includes some of the center-to-center events from our ATMS, which we run Southwest Research Institute. We run SunGuy, which is our local install. Basically, it's a form of active ITS. And then also some fused data sets that we put together that we also still run on premises for the fusion, but then we post the detection information up, as well as some Waze events. And then we're also are pushing ATSPM events up to the cloud as well, to be able to display it and to be able to share it statewide. When we look at accomplishments so far, I think the biggest things we've gotten where there's been support from IT and from traffic management on how to go ahead and build informed systems, and we show the quick value that we can return by successful implementation. We've been able to improve our documentation. You see just a small sample of that over on the right. We've also instituted a data handler, which is Kafka, which is where we're reading a lot of our data sources into, and then allowing the Kafka consumer in order to pull it out to our downstream systems. We've seen this has been really helpful for us to improve ease of access to data sets, to be able to set us up to more easily to move things around. When we look at opportunities for us going forward, what we are really focused in on is now moving our universities over who has historically used SneakerNet in order to get access to our data sets for them to do research work on, and then they deliver products that we then try to productize within the TMC, and we end up rewriting their code. Instead, what we're looking forward to is the ability to have the university go ahead and develop directly on our AWS cloud. And then for us to then be able to use the fruits of that labor and move it into a production system without having to basically reinvent the wheel so that it runs in our operating environment versus in the one that they went ahead and wrote it in. We do see some challenges that are still present that we're still trying to work our way through as an agency, not related to the pilot, but just looking ahead at some of the bigger issues. The state does have that very robust system that's requiring two-way communication, which has a lot more complexity that's kind of getting built out around the idea of how do we share data and how do we deal with some of the security concerns with it. And there's been some back and forth that's gone on throughout the state. The good news is we've seen we can successfully move to cloud, and there's a lot of support for it. Now it's just a matter of us figuring out how to tackle these individual issues for that bigger system. And we know that there's a huge need for it because of where things are headed with connected vehicle technology. So we know it's inevitable that we're going to get there. And based upon showing short-term successes like we did with this particular project, it's building internally the desire to go ahead and be able to move forward with it and support from the operations personnel. With that, that was what I had for you today. I think questions, if you could put them into the Q&A. And with that, I'll turn it back over to Kelly.
Thank you, Jeremy. Great presentation, lots of information. Okay, so we have another poll question before we move on to the next speaker. So which of the following best describes data storage and processing at your organization? Mostly on premises and traditional data systems, a private cloud, commercial cloud services, a mix of on premises and cloud, other or not sure. Just a few more seconds and then we'll close the poll, share the results. Okay. Okay, so about 50% mix of on-premises and cloud. And then 17% mostly on premises in traditional data systems, and another 17% in not sure. And then one response in commercial cloud services. Thank you. All right. Our next speaker is from the Arizona Department of Transportation. Joseph Jones has worked at ADOT for over 3 years in the Systems Technology Group in TSMO. Joseph has a Bachelor of Business in Organizational Management and a Master of Arts in Economics and Econometrics. Before coming to ADOT, Joseph held various tech and management positions in a variety of industries. So Joseph, the floor is yours.
Hi, everyone. How are y'all doing today? All right. Go ahead and get started. So the main goal of today's presentation is to walk you through the processes of using the, in the context of the roadmap for managing data from emerging technologies, like basically using the guidebook as kind of as a walkthrough from beginning to end and kind of where we're at on that path. So a little about Arizona. It's a rapidly growing state. A lot of businesses and a lot of people are moving here, and it's been going on that way for several decades. And so as naturally as you can guess, our roadways are becoming fuller. So this is one of the motivations in using technological products as opposed to using physical products to help manage traffic. A little about ADOT. you can see, about 3,700 employees, about 900 maintenance employees, and we manage a decent network given this large state size of our states. And naturally, due to the fact that most of our infrastructure is new, we are rated really high, and our pavement our pavements and bridges are one of the best in the country. All right, so here's our use case. So basically, our use case was helping enhance our traveler notifications messaging program. And in doing so, the Maricopa Association of Governments, MAG, basically set up a contract with a 5G telecom provider to perform a pilot of utilizing cellular V2X technology without using physical roadside units, which are cost prohibitive, unfortunately. So we're trying to find a technological route. So our motivation, as mentioned a little earlier, was to enhance the traveler information messages system to inform roadway conditions within the state, naturally to improve mobility and safety, and to also expand data coverage for roadway conditions using probe data. Some challenges and lessons learned in the beginning, because the state of Arizona has a cloud first initiative, which I'll talk a little bit more about in a moment. That there wasn't too much issue with getting access to there wasn't too much issue for the state embracing a cloud first methodology, but it was actually getting the permissions to utilize it. As I work in the systems technology group, which we were the first business unit outside of the IT department at ADOT to utilize the cloud environment. So that naturally caused some, things took a little longer than expected. Then we also were now having to, because when we performed the pilot, as mentioned previously, that was led by the MAG, we had to refactor some of the code so it would work in the cloud because of some of the packages that AWS, they have slightly different variants of the packages, and you have to make adjustments. Then we use some production APIs in the dev environment, and from our security team, that's not an ideal situation to have. Then now the good news is, though, we now have knowledge to implement other traffic notification processes and other IT platforms as a whole into AWS, as not only our group of systems technologies gained experience utilizing the cloud, and we're continuing to learn because there's a lot to learn naturally, but the rest of ITG, which is the IT group within ADOT, they're also gaining more and more experience as they're adhering to the state of Arizona's cloud first initiative. Some challenges we had initially was trying to get the linear referencing system to work correctly, because we are also calculating some geofencing, but I'll explain a little more of that as we go on. So the thought process behind this was using the first principles thinking of trying to break down the problems into smaller segments to basically try to identify what we can solve or resolve in a easier manner. And then utilizing the guidebook, which was a real help for that. We did some simple, some standardized processes that are done in a lot of tech companies, like having a naming convention within your data lake. We assessed the pros and cons of different AWS tools, and we gained exposure to a variety of tools. And that way it gave some ideas of what else we can do for other projects within the TISMO division. So step number one, as I mentioned earlier, is developing an understanding of the cloud. Was the state of Arizona already recognized the need for going to the cloud, given the size of data, and the velocity of that data? The state, that's why I mentioned earlier, they're already embraced the cloud first initiative. So, and mentioning too, the ADOT's ITG or IT group, they're the ones that have started basically transitioning a lot of existing servers that were on-prem into the cloud environment. And some of them were even comprised, you can call them as lift and shift processes. Because as AWS has some pretty nifty tools to help make that happen. But that being said, there was a lot of, so there's been a lot of transition. While that's good news that the state has this in the forefront, but for, I guess we would be considered a customer, there's still some lag effects given the fact that ITG is highly busy, and so that kind of causes some small delays for us getting the access that we needed to perform this project, to transition the use case of the traveler notification program into the cloud environment. And by the way, there are several different traveler notification initiatives, notably roadwork warning, curve speed warning, and back at queue, as well as TSMO, where our group, we received some basic safety messages, but the main issue, or the main component that we're focused on implementing in the cloud, was the back of queue warning program. So here's what it leads to our use case. And so I'll tell you a little about the back of queue program to give some context. So imagine you're driving down the freeway and things are normal. You're going, normal speed limit or whatnot. And all of a sudden around the bend, there's a dramatic drop in speed and you slam on your brakes. And you might think to yourself, I really wish that I would have had a notification to tell me that so I could have prepared or slowed down a little earlier. And hence the cars behind me would slow down a little earlier and would reduce the instances of a bottleneck. So the goal, as we mentioned, was to improve, to give the traveling public within the state of Arizona more options or more information that they can use to help them drive safely, as to, like I mentioned, improving mobility and safety. So what we did is, again, with this back of queue warning, what we did is we used a probe data provider that would notify us where there's a back of queue event. And then we took that lat long of that event, and then we used our linear referencing system data to calculate in 1 mile intervals, 3 miles upstream, to basically tell the travelers, there's roadwork ahead, or in this case would be the back of queue warnings up ahead. So basically it'll help the traveling public basically alter their driving behavior. So that was the main premise behind that. And then also we did geofencing. So we calculated the geofencing, because naturally, if you found there was a traffic issue on the 51 in Highland, this is a freeway in the state, in Phoenix, if you're going northbound, you wouldn't want to receive a notification going southbound on 51 and on the 51 in Highland, because that would be, false positive. And so basically we did the roadwork geometry to ensure that wouldn't happen. So that was the main thing. And we did all this work using Golang and Python on our computers, just on a laptop. And then we interfaced with the 5G telecoms, their protobuf process, which we sent the data to the AWS wavelength, which they managed. And this allowed the data to be sent rapidly to the smartphones, which the 5G telecom provider created an app for to test this out. So one major thing too, as everyone here can guess, is it's important to get buy-in from someone, at least one person in senior leadership, to ensure that the project can move forward and can gain the recognition it needs, and for it to be potentially implemented. So in our group, the ADOT's TISMO senior leadership supported the pilot that we had worked with MAG and the 5G telecom provider to ensure that we were able to move forward with it. And ADOT's main way of supporting the project was providing the labor. Myself and Shafiq, who is on the slides as well, and then John Roberts, who helped kind of point us in the right direction when we needed it. So that being said, that was important part of the process. And then here was another big one, as I mentioned a little earlier, about us getting access to the cloud environment, because initially our IT group was the only group within ADOT to have access to the cloud environment, and our group was the first one outside of the IT group to get access to it. And so basically what this allowed us to start to alter the code and to change it to basically run it in the cloud. We first just did some really small stuff, like we used Cloud9, and then we started transitioning some of the code into Lambda, and then from there. So I guess it's no secret as AWS, but I was trying to be vendor agnostic on this presentation. But at any rate, it's pretty well documented. But all that aside, we were working through the process to basically make sure we had the necessary tools to ensure that we would be able to run this in that cloud environment. And we also took into considerations of if we were to productionize this, or was thinking ahead of what would need to be done for that to even occur. But so here's where we developed the use case, as I mentioned previously. And so we made some, like I mentioned, we already made some edits. And then we went forth with demonstrating the value to others in the business units. This is the step that we're working on now. We did some presentations with different, not just within our group, but with outside agencies. We gave status updates of the progress of the project. And it's not just the business units within ADOT that is shown, or ADOT within the states that's shown interest. Some outside DOTs, notably one, has shown interest in implementing the project. So I thought that was really good news, because the way we wrote the code, it's very easy to edit and change to fit your niche case. Notably, each state has a little bit different linear referencing system process. So that is good. They would just make some edits on that, and then the project should work accordingly. We're still doing some work in progress, which I'll touch base on a little bit. So here's demonstrating the value of the executive leadership. This is our stage that we're in now, because if we were to implement this project, we'd have to factor in things of maintainability, security, and as well as looking into basically and then looking at getting any other feedback in relation to this project. But right now, this is the stage we're in. So we're right now in the midst of presenting it to our senior leadership in hopes that we'd basically be able to transition and move this forward with the traveler notification system enhancement. And also we're looking on deploying an API, just a REST API, where it's modular, so any vendor can use it and they can manipulate the data as they see fit for their use case, whether it's an OEM, whether it's another DOT, whether it's a map service, or it could be used on a whole host of entities. So here's the step 2 that it's important. Once if we get a formal approval by the senior leadership that, yeah, we can move forward with operationalizing this plan, naturally we would want to store all the data, because during the pilot, we didn't really store a lot of the data. We just would run it, and then we get printouts of kind of lat long of where the vehicles were and and so on and so forth, or not even the vehicles, but the like events, like where the back of queue events were taking place. So those were the kind of the main things that we had to work through. And then next steps, as I mentioned a little earlier, is confirming that the data pipeline that we have is suitable for our needs, and then would change that as needed. Because one idea that I had was, instead of using Python and Go for performing all the calculations, I can convert the Python code, which is that the ArcGIS group here uses, and just converting into Go to make it a little more streamlined, and in hopes of improving maintainability of the code. And then, of course, working with our IT group and the security, and then modularizing the code base to make sure that it's modularizing the code base. So to use for other traveler notification services. And I'll look forward to y'all's questions, and let me know if you have any, and thank you.
Thank you, Joseph. Yep, it's just, again, if you have any questions for Joseph or any of the other panelists, just please put that in the Q&A chat box. And we have one more poll question before we go to our final speaker, and then we'll open it up for questions. So if we can share that poll question with the audience, please. So which of the following best describes the use of cloud services at your organization? Policies preclude use of cloud services. Cloud services are used as an exception by some departments or divisions, or for specific data or projects. Currently in the process of developing processes for organization-wide use of cloud services. Implementing processes for organization-wide use of cloud service. Nearly all relevant data and processing is cloud-based, or not sure. A few more seconds. Okay, let's share the results, please. Okay, so we only have 9 respondents. So 5 of the 9 are not sure. And then 2 cloud services are used as an exception or for certain projects, and then 1 each for implementing processes, or nearly all relevant data and processing is cloud-based. So thank you. Okay, so going on to our last presentation. This is the district DOT's project. And so we have Christian Williams and Eric Garbasic. Christian is the Enterprise Applications Manager for DDOT's Office of the Chief Information Officer. He oversees DDOT's application teams and coordinates across departments regarding new acquisitions, updates, and sunsetting of existing systems. In his 30 years in IT, he has worked across the spectrum, including enterprise application development, project ownership, project management, and as serving as an executive stakeholder. His experience in the federal sector, private sector, and with local government includes time spent as a contractor. And Dr. Eric Garbasic is a data scientist supporting the DDOT Office of the Chief Information Officer with process engineering, data architecture, and analytics, including spearheading the implementation of the NCHRP 952 Guidebook. He has over a decade of experience in leading quantitative analytics teams across academia, the private sector, and FFRDCs. He holds a bachelor's degree in physics from Lawrence University and both a master's degree and PhD in physics from the University of Twente in the Netherlands. In his free time, he's an avid user of the extensive and excellent bike infrastructure around the District of Columbia. So I will turn it over to Christian and Eric.
Hey, thanks a lot, Kelly. So I'm Eric. I'm here on video. Christian is also in here in this room with me.
Good afternoon, everyone.
And we are the last ones to present today. So we're going to do our best to not hold you back from this wonderful Q&A. And I'd like to start off by thanking all the other speakers for their excellent presentations. This pilot has really been a very interesting experience for me and for DDOT. And it's always great to hear what other departments of transportation have done in this space. Our goal within this program aligns well with one of the major DDOT and district-wide goals, which is fundamentally reducing the number of single occupant vehicle trips within the District of Columbia, primarily by encouraging other modes of transportation. And this aligns with two major strategic programs here. One is the Strategic Transportation Program known as Move DC, which is a long-term plan. It has seven high-level goals, of which safety and equitability are two of the primary components of this project. And encouraging sustainable transportation within the district is a big third one. These also align with our Vision Zero, which is aiming to reduce the number of traffic-related fatalities in the district to zero. And single occupant vehicle rides are really a major source of both congestion, in a lot of cases, injury and fatalities within the district. 2022 was a pretty bad year for the district. 22 fatalities on bikes and foot, and something like 5,700 injuries due to vehicles. And so the district is a compact urban space. It's about 68 square miles. And there are many alternatives. As Kelly mentioned, I'm a big fan of a lot of the alternative transportation and the very robust bicycle infrastructure here. And alternatives to vehicles include public transit, bicycles, scooters, walking, ride sharing, all of that. And DDOT in particular is really committed to improving the accessibility and equitability of these alternative modes of transportation. One of the ways they're doing this is by a plan that's currently aiming to add about 20 new miles of protected bike lanes across the district. So with that being said about what our real goal is here of supporting the decision makers, the engineers, the planners with reducing single occupant vehicle trips, I want to talk about the pilot project that we're working on here, which is really focused on micromobility. So micromobility are typically those electric powered scooters or bicycles that you see out in the streets of urban areas. There are a couple of different vendors within the district. And DDOT really wants to understand how these are being used, and ideally also how they are maybe not being used. If you want to encourage the use of a new device, a new technology, a new platform like a micromobility scooter, in places where they're not currently being used, you have to be able to understand how they are currently being used and then infer how they could be used in order to plan for changes in infrastructure, in policies and regulations, and so on and so forth. And so to really understand how to increase the usage of non-vehicle modes of transportation, there are really three considerations here. The first is the amount of data that we have. We are pulling from the Open Mobility Foundation mobility data specification feeds. And over the past 2 years, we've recorded about 10 million trips within the district. So this is a pretty substantial amount of data. You could process this on a laptop or a desktop computer. You don't necessarily need a huge distributed computing system like a cloud, but it is getting to the limits where you start wanting to look at distributed computing. And so it's a good data-centric use case for this kind of a pilot. The second up is security. These data are considered to be highly sensitive for a variety of reasons. The primary one is personal privacy. You can, in theory, re-identify trips using this data, even though the data themselves have been explicitly de-identified before we get them at DDOT. And so we have a mandate to make sure that the privacy and security of residents and visitors to the district are secured. And so we have to conduct sensitivity analyses and other kinds of analyses to understand how best to secure that data, to ensure privacy, while also letting the public know how their public space is being used and giving access to the public, to university partners, to commercial partners who would like to use this data to understand better how the space is being used and how it can be used better. And the final point, which I alluded to earlier, is missing data. As you can probably imagine, these kinds of devices, scooters in particular, are very heavily used in areas that are close to public transit nodes, entertainment centers, and probably less used in more residential areas, more distributed areas. And so what we're also trying to get to here is trying to figure out, how do we understand how scooters would be used in areas where they are not currently being used, based on associations of the parameters, the demographics, the geographies of areas where they're not being used, and comparing those to areas where they are being used. So those are really the three major considerations that we have in this pilot: the amount of data we have, the security of the data, and understanding how we utilize what we know to infer what we don't. This whole project started for us back in about January 2022. There was a buildup where we scoped out the pilot. We built out partnerships, coordinated work plans, and then the Office of the Chief Information Officer, where this work was being actually conducted, started actively working in May 2022. At the time, we decided to use an on-premises cloud system. So this is a Cloudera data platform that I'll discuss in the next slide. It is not an Amazon cloud, it's not a Microsoft cloud, it's something a little bit different. We spent about 2 months ramping up on that before starting to understand the data itself and build out some of our analytics pipelines. And then we had about 2 months to actually conduct our analytics before we had to close out the analytics phase and start working on the documentation. So all told, the technical part of this project was about 5 months and involved 4 primary stakeholders. The first is our micromobility manager at DDOT, who is really responsible for owning the data, setting requirements for how these dockless mobility devices should be operated within the district. And they're also the primary consumer of all of the results that we're producing. The Office of the Chief Information Officer was developing the analytics, setting all the data governance, all of the privacy policies, the security policies for the data itself, and working with the research manager, the micromobility manager, and our Office of the Chief Technology Officer within the DC government to really build out all of the connection points that we needed in order to achieve that primary goal. All of the infrastructure here was really done or really managed by Octo. So the on-premises cloud, the security of that cloud, and all of the ETL pipelines for the data, those were all managed by Octo. And OCIO, myself, Christian, my other colleagues were really consumers of the platform that Octo was hosting there. So it's a little bit of a different cloud environment than other people have talked about. And the way that the responsibilities broke down in terms of the data itself is shown here. All of the different bubbles are color coded according to the primary stakeholder. So the micromobility manager, of course, is the key consumer of all of this analytics. They're that purple bubble over to the right. Octo was really responsible for the infrastructure, the servers, all of the stuff around the servers, the networking, the authentications, the credentialing, the security, and all of the ETL pipelines to pull in all of the dockless mobility data. The OCIO did everything between the ingestion of the data and the production of the results. So extracting all of the raw data, further de-anonymizing it, or sorry, further anonymizing it, building out some more transform data, cleaning it up, and finally producing authoritative files that we use for the endpoint analysis. So there was a division of labor here that you may not find if you are working entirely in a full cloud environment. But again, this was due to the requirements of having an on-premises cloud. One of the benefits of this is that we had direct points of contact with the people who owned every component of that on-premises cloud. And it was really a pleasure to work with this team over in Octo. They were very knowledgeable, very friendly, and very responsive to all of the queries that we had and all of the issues that we raised with them. And the cloud looks like this. They call it the DC Data Lake. It's a Cloudera data platform. It has all your normal distributed computing bells and whistles. It's a Hadoop file system, has a resource manager, a couple of ways to query into that data using your favorite SQL query engine, and then a separate server hosting Jupyter notebooks So you can run your Python code, you can run your R code, you can run direct SQL queries, and there are ways to interface directly into the data lake. So we have GitHub that we can attach into it. We can attach ArcGIS endpoints into it. So there are a variety of ways we can get data in and out, and allow, especially our primary customers, to really utilize the data and the analytics that we're producing here. So the key benefits here are because it's on-prem, there is all of that really fixed storage and computational space available. You don't have to worry about scaling out your systems. You don't have to worry about the costs associated with that. Most of the costs here were upfront capital expenses, and the operating costs are relatively low compared to the equivalent full cloud infrastructure. On the other hand, there are some drawbacks because it is an on-premises system. It doesn't have access to all of those applications that you normally find in an AWS or an Azure or a Google Cloud. And it was a little challenging getting some of these applications to function in the Octo data lake here. So as I said earlier, data protection is a huge deal for us. It's one of our primary concerns when dealing with this data in particular. And all of the data really comes in the form of individual events. So you get a ride pickup, a start event, you get a ride drop off, an end event. Each of these has a spatial coordinate, GPS X and Y, or lat long, and a time component. And these are really precise. In the open space, your location is about a meter of precision, about 3 feet, and your time precision is sub-second. So within this data, even though there's no personally identifiable information, you can easily see exactly when somebody picked up a ride and exactly when that ride was dropped off. And so there is a potential for identifiability here if you have enough observations. You could potentially see repeated patterns, you can see repeated pickups, repeated drop-offs, and you can start building patterns of life to see whether you can find specific individuals. These data are also business sensitive, right? The ways that some of these companies distribute their devices around the district is proprietary. And so we have to be sensitive of their trade secrets and not reveal any of that information as well. So we have to be aggregating, we have to be de-identifying. The only question is, how do we do that? There are many different ways that you can anonymize data, you can de-identify data, and we chose to do binning. So the question first when you do EDA is, well, what are we actually doing with this data and how do we understand this data? So very high level, of all of the 10 million trips or so in the district over the past 2 years, about 80% of them are scooters. These are the electric scooters you see, the little two-wheel things with a handlebar in front. Of all of the trips we see, the median duration is about 300 seconds. So about 5 minutes, whereas the mean value is quite a bit higher because there's a very long tail on this distribution. There are some very long rides on scooters and bicycles in particular. And the median distance is like 1,000 meters, right? So a couple of city blocks. All of this sets the parameters that we can use for understanding how granular we can bin the data before we start losing resolution on the analysis we can do. Other ways we can look at the data include looking at the speeds of different vehicles and different trips, time of day, day of week, and holidays. And so what you see here, top left and top right, these are just a couple thousand observations that we have in the data. Up in the top left, you see that the bikes are those green dots. They tend to move a little bit faster. The speed is increasing to the top left of this picture, whereas the scooters are all limited by regulation to 10 miles an hour. And so none of them are really above and to the left of that black line. We wanted to focus on scooters here because they're about 80% of the total trips. And what we found looking at the data is that there really isn't any distinction between how long trips last and how far they go depending on time of day. So you can break out the data by morning or midday or late night or any other combination, and you see roughly the same types of trips looking at the entire district as a whole. Where it gets more interesting is if you look at the day of the week and the time of the day per day of week. So if you look at a typical Wednesday, you see a morning rush hour, you see an evening rush hour, and you don't see a lot of late night activity. And that's that blue line down in the bottom left there, where you see 8 a.m., you see a decent number of trips. Later in the day around 5 p.m., you see more trips and you see a little bit of a lunch rush. On a Saturday, a typical weekend day, you don't really see that morning rush, and you see more late night trips, as people are out enjoying all of the pleasures that DC has to offer. Where it gets particularly interesting are holidays. July 4th is a good example here, where you don't see any pattern that's anything like a weekday or a weekend. It's a very different type of behavior that goes far into the night. And so all of the takeaways from this go towards informing how we think about binning and aggregating data together. Most of the trips of interest that we're looking at here are going to be longer than 50 meters, right? We don't really care about those really short trips, either in space or in time. And we also have to be very cognizant of the fact that there's different patterns of behavior on weekdays, weekends, and major holidays. So all of that combined now gives us enough information to actually build out our analytics pipeline, which has a lot of individual steps in it, but what it ends up with is a grid of cleaned and filtered data where the pitch or the size of each of these individual bins is about 50 to 100 meters, depending on the type of analysis we're doing. And what I want to highlight here in the bottom right are two different ways of looking at the data. What you see are the starting points and the ending points of morning weekday rides, and the number of trips that either start or end in a given grid square. And you can see some already very clear patterns of behavior. That red line, or that red arrow, for example, it points to an area where there isn't a whole lot of ride starts, right? It's kind of a dark area, but a lot of rides are ending up there. That is the Golden Triangle District in DC. That is a very commercial district without a lot of residential area. That's where a lot of people are riding their scooters in order to go to work in the office. The orange arrow points to an area that's kind of residential. That's kind of a 14th Street, 16th Street up in Northwest DC, where you see a lot of rides starting, but not a lot of rides ending, right? People leaving their homes to go to work. And finally, that little blue arrow in the bottom right is just on the south side of the Capitol building. Again, not a lot of rides are starting there, but there are a lot of rides ending up there as congressional staffers and others go to work again. So just through aggregation and visualizing the data, we can already start to see patterns of life appearing. And if we then animate this over time, what we can see are sort of the life cycle, the breathing of the city over time. And so you can see here, orange means that more scooters are leaving an area, blue is more scooters are arriving. There's a date or a day of the week and a time up in the top left. And you can watch for a little while as you can see how people are utilizing these dockless mobility devices across the district. Most of your attention is going to be focused in the center because that's where the activity is, but the real interesting thing that we're looking at is how do we understand the ways that dockless mobility could be utilized in the areas that don't have a lot of data. The bottom right area on this map, wards 7 and 8 in DC, the top right area, which is Ward 5, all of these are historically disadvantaged communities that would benefit tremendously from equitable distributions of dockless mobility in their areas. So we really want to understand, for example, how these scooters are being used in areas where we do have a lot of data to understand how we can encourage their use or other uses, other mobilities in areas where they're not currently being used. And my parting set of analysis here is the final thing we were working on before we had to go pencils down on the analytics, which is a machine learning approach to understanding patterns of behavior across the entire district. Every color you see here represents a different type of behavior. And these types of behaviors are really based on when people are using the dockless mobility devices, when they're leaving areas, when they're arriving at areas, and looking at them across the entire district. And fortunately for us, we can start seeing that those areas that didn't have a lot of rides before actually do have some colors. So the zoomed in area here shows central DC where there are a lot of rides, but you can see even down in the bottom right wards 7 and 8 and then top right ward 5, there are a bunch of colored dots, which starts giving us information about what kinds of behavior we can expect to see across the entire district. And we can start associating other types of data as well. We can associate demographics, financial, transit node locations, bike infrastructure. Many other types of data sources can be incorporated into this data source now to really build out and understand better how are these devices being used, and going back to our original goal for this, how can we reduce the use of single occupant vehicle rides across the district to encourage a safer district with more equitable access to the entire district and a more sustainable transportation infrastructure. And so some concluding text here. I won't read it for you. I think I've covered all of it already. Again, I want to thank everybody for attending. Thank you, Kelly, and thank you to the NOCOE group for giving me the opportunity to present here. I look forward to all of your questions later on.
Thanks, Eric and Christian. Okay, so let's transition. I see we have one question in the Q&A, so I hope that the people that are still hanging on here in the webinar can maybe throw in another questions. If not, I've got some questions. But do any of the panel members want to answer this question? What is the difference between private cloud and commercial cloud?
I was hoping I could defer to somebody who's got the background with cloud computing and data. I could take a guess at it, but I'm just not sure myself. Yeah, sorry.
Eric or Jeremy, do you, if not, I can take it, but I just want to see if anybody on the panel wants to maybe jump in there.
I know how we will use the term, and I'll defer if there's a better answer. But normally when we start talking about that there is a private cloud, right, that's someone who is offering that as a service, it's still running on physical servers. That might be something that, like, we have our own private cloud that we'll go ahead and stand up on servers, we'll make available through an internet connection. However, if we're going ahead and looking at a commercial cloud service, when we use that term, we're referring to the big three. So that's when we start talking about Google, when we start talking about AWS, we start talking about Azure as being really those providers of commercial services that you can go on and you can register for that service yourself online, as opposed to when we've gone ahead and done work, whether or not it's us offering cloud services effectively to our like signal maintaining agencies. That's been looked at as a private cloud. And then when we've also gone ahead and contracted out for services, there'll be people that you as like a utility service, you couldn't purchase it from them. But because of the size of the deployment with the department, they may stand up their own physical servers and maintain them for us. And those act as a private cloud. That's a differentiation that I've heard on the terms. I don't know if that's technically correct, but that's how we've used them.
Thanks, Jeremy. Eric, did you want to take a stab at that, or?
I fully agree. That's a great answer.
Okay. All right. So we have some questions here. Eric, while I have you off mute, what are some of the advantages and disadvantages of the on-premises cloud, at least as you've experienced working with the district on-premises cloud system?
Yeah, it's a great question. It's a huge advantage if one already exists for you. It means that your setup time is very limited. You already have a system. Ideally, it's already connected to your authentication. If you have an Active Directory system, that's always a benefit. One of the disadvantages is that an on-premises cloud has a large upfront capital expense, right? You have to buy the servers, you have to buy the storage, and you may have to hire people who are specialized in running those kinds of systems. Whereas in a cloud server, like an AWS and Amazon, or sorry, an AWS and Azure, a Google, you don't have that upfront expense, but you do have much higher operating expenses. And so you need a different set of skills to operate there. You also need to be very careful about your scaling and putting up guardrails on all of your computations. If you decide that you want to have a really beefy server and you accidentally leave it on overnight, the charges can rack up very quickly. And then the final thing I talked about is the flexibility of the systems. Cloud services, AWS, Azure, GCP, they're all built to be very modular and very easy to connect to other services. And so it's very simple to really spin up a new service, connect it into the rest of your infrastructure, and shut it down again when you don't need it. It's harder to do that with an on-premises system. Not impossible, it's just a little bit trickier because of the nature of it.
Thank you. And one more question for you. How do you balance the level of aggregation that you talked about with the micromobility data with the risks to privacy?
That's a question that we continue to struggle with. It's something that we work on actively all the time. The data itself is, as I said, very highly sensitive. And even with the level of aggregation that we had, right, a 100-meter bin size may actually not be great for more sparsely populated areas, right? In the district, we have a very dense population. The entire district is already built out. We can't build it out any further. And so population density can really only go up from here. So for us, 100 meters was a good balance between the number of rides that we would get per bin, and the detail we needed for our analysis. But that's going to change jurisdiction to jurisdiction. It's going to change by geography and by use case. The other part is what I showed today was just looking at ride pickups and ride drop-offs, origin and destination separately. If you connect these two, you have an entirely different set of calculus you need to do because you now have full origin destination pairs. And if you have enough of those, you can really easily identify individuals. So there's a whole different set of analysis that we're working on right now on understanding what the level of aggregation needs to be in order to maintain privacy when you have the full origin destination compared to just either origin or destination.
Thank you. Okay, so we have a question from Pavitra. I don't remember which presentation covered linear reference system. So this is Joseph with ADOT, I believe. Curious what has been the advantages of using LRS, and also would like to know which tool or software was used for the LRS.
So our linear referencing system is just naturally, as you already know, it's a plotting the lat longs of our road network. So basically by using that, we used the tool, I think we used ArcGIS was like kind of the facilitator. I had someone in our group who's an ArcGIS programmer help us with that to help at least facilitate getting the lat longs. What we did is say when there was a danger slowdown event at one point, then we performed the calculation from the nearest linear referencing data point, like the nearest lat long that's within our state network. And then we performed a calculation. So we would measure the distance from that. So we'd be able to accurately measure 3 miles upstream. So it work correctly. But in short, we used ArcGIS and Python for that part and to calculating the geofencing. Does that sufficiently answer your question? Okay.
Daniel, how many of the panel members used the data capability self-assessment? So that was a tool that was provided in the back of the guidebook. And for those that did, was it completed by an individual or a team? And lastly, what were the titles of those in the room for the assessment? So did any of the agencies, the participating agencies, did any of you walk through that? I know we did not walk through it during the 1.5 day training because there wasn't really time for that. But either before or after the training, did any of you use that those questions in that self-assessment?
See, I can jump in on that one to start with. So we went ahead and used it with 2 different teams. So we went ahead and first, and this was, I think, before the guidebook was officially published. We went ahead and took that back with the team that was specific here in the district, and we went ahead and took a look at it. Then we took a wider look at it with some of our developers and brought them into the room and saw how that kind of changed our answers and what we felt like were our capabilities. And I think it identified some areas that we started focusing our program on in a little bit of a different area by going ahead and showing some areas that we did not feel comfortable with. And we were surprised at how similar the responses were when they were a smaller team versus with a bigger team. We thought there was going to be a bigger gap. It seems like the more people know, the more that they don't have confidence that they know everything. So it was, to us, it was an interesting, experience to help us to be able to see where we were, and we were surprised that it was consistent regardless of the technical capabilities in the room.
My internet cut out just a bit, but did you address what were the titles or the roles of the people that did that assessment?
Oh, I'm sorry, I did not. So I was a TSM&O program engineer. I was in there. Our project manager was in there, as well as our project manager supervisor for the initial one. And then we went in and brought in developers. So that included our GIS administrator, as well as our Python developer and our C++ developer, were the ones that were in there for the second group that we went ahead and assessed.
Great, thank you. Russ, did you want to jump in there?
I was just going to say in the chat, I noted that Rhode Island did not use it for this effort, but I'm kind of disheartened that we didn't, because we had success with other efforts elsewhere, some with TSMO, with using similar assessments. And every time we've done one, I anyways found it very helpful, showing where your weaknesses are, like they were saying. So we didn't use it here, and I wish we had. Hey, it's not too late, right? We could still use it. It's in there, and maybe we will someday, but we didn't use it. I'm glad Florida did.
Thank you. Okay, so Russ, while I have you, you had mentioned during your presentation that there was a number of IT challenges that you had kind of going through the process of getting approval to use the cloud and that whole process. What do you feel is one of the biggest hurdles that you had to overcome, and what do you feel was the biggest reason why or how you were able to successfully overcome it? Or maybe that's a question more for Steve, but either one of you can jump in.
Well, good question. Steve, do you want to try to answer that one, or I'm happy to if you don't?
Yeah, no, I can certainly answer that, Kelly. I mean, I think like others, there wasn't any direct policy decisions that have been made about moving to the cloud, and what we had seen with many of our systems, it was being done on an as-needed basis. Since then, we've seen over half of our systems move, off-site and being hosted in the cloud. But when we started this process, there was really no guidance or support from IT in this, and there was more questions than answered. So one of the things, Kelly, that we needed to do is because from a GIS standpoint, we are at that point where we had to make this decisions of continuing to invest in the kind of the on-site systems, or move to a point where we were going to leverage kind of a cloud hosting environment. We directly engaged IT. And I think, for one, they learned a lot more about what our business needs were, which I think was very helpful. And it's been an ongoing discussion, because I know, Kelly, we've had a lot of check-in points over the last, several months. And I can honestly say right now we're working with them as a team to actually develop the RFP to go out to bid with. So where in the past we would kind of take the lead on that. So, we accomplished our goal, for one, to get them engaged in the agency, because like Russ said, we have limited staff, and our staff was maxed out with the current systems that we were supporting. So we knew we needed to kind of reach out and bring a vendor on. But we also needed to make sure that when we moved in this direction, that IT was supportive of that effort. So, that was the biggest thing for us.
And moving forward, all of the things that you guys had to go through to kind of get to where you are, is that is that going to just make it a lot easier now in the future for you or other groups in RIDOT to be able to use cloud or develop, put data in the cloud or develop projects?
Yeah,
Or-
I think no doubt, both for RIDOT and other state agencies, because again, the state being small, our RIDOT staff actually supports the state GIS infrastructure as well. So with what we were showing, we're actually doing that for other agencies. So they're going through the same assessment, and the next logical step for them is to kind of follow in our coattails for the direction we're heading. And then the other thing we've seen, and Russ can touch on this, we work real closely with our transit agency, with our EMA, our 911. So there's already been discussions on where we're heading with that.
Great, thank you.
Yeah, statewide CAD RMS initiative. We know we can, Steve and I are people who know we can do better with sharing the data. And again, as we said at the top, there's so much data available today, and there'll be more coming, that it makes sense to be nimble and get value out of it. So that's what this is all about. I would just say on the latter point too, I think it's just communication. You said it, Steve, that do it is, they got their own initiatives. And people like me like to think that IT, that don't they support everything, like Steve cuts off, he's GIS, they support every operating unit at the DOT, bridge, design, planning, TSMO, traffic signals, right? But there was that communication lapse, and they have all these policies in place for good reasons, security, well, who knows, value and all that, right, Steve? But they just didn't, they needed communication from somebody like Steve who can say it well to make the case, and then finally say, oh yeah, you know what, we're here to support you. So it's longer than we hoped it would take, but it's just communication in the end, like everything is in the world, right? It's communication is key. So,
Thank you. Joseph, here's a question for you from one of the attendees. I am curious on how the back of queue warning was generated using the HERE data.
Oh, we used the probe data, the INRIX. They have a INRIX data. The probe data, the way they basically generated it is they have a bunch of like different vehicles that they have where they collect data from. So basically they have a sufficient saturation rate within the network to basically be able to quantify and say, yeah, these cars are slowing down too much or too fast. Like the deceleration rate is too high. So that's how they're able to label that the back of queue event is occurring. And then when it does too, it's dynamic and it updates once a minute. So as you can guess, sometimes back of queue events, they can grow over time. So naturally that lat long point will shift each minute until the event, and it will shift. Yeah, so basically it's adjust to the real-time events of the roadway.
And they provide that back of queue data, correct? They kind of do some of those calculations.
Well, they send, so basically what they're doing is they're using their vehicle data that they have access to, and then they send us a lat long saying, hey, here's an event. And they could be done for a variety of products that they can do that with. But the main one that we're focused for this project was the back of queue warning.
Thank you.
You're welcome.
Jeremy, question for you. You mentioned that you had this on-premises system when you started this, and one of the goals was to be able to more easily share the products or the tools that you all were developing in District 5 with other districts. Could you talk a little bit about how you worked with, I think it was District 3, right? District 3?
It was District 3, that's correct.
And how they are able now to get access to that tool that was really pretty much before just something you were using in District 5.
And let's be true here, like it's also selfish that I not only want to give the tools that I've got, but I want to take theirs too. So what we went ahead and have been able to do is by putting this up into a cloud hosted system, right? So hitting a URL, where they can authenticate against it in order to be able to grant access. This is no longer about having to navigate between different systems where we'd have to build routes into routing tables to get through some relatively complex areas. When you start looking at it for the state of Florida, that means that we'd have to actually jump through 2 intermediate systems to get to District 3, which can get complicated at times, and maintenance becomes a problem. By everything being up on AWS, it's as simple as navigating to a website in order to be able to pull the information, to be able to access it, and for them to be able to look at the tools. But they can also see the supporting logic that exists behind it. Similarly, they've got some tools that are built off of the same data sets. They go ahead and look at information related to trucks and how that's applied to their freight network. And that's what we're hoping to do next, is to leverage the tool that they have gone ahead and developed for their freight management team, for us to be able to use that in District 5. And that's where we see the value of this, is instead of these systems that are built and then they're used by one set of, one group within the state, and they get tremendous value out of it. And then we have to pay to go ahead and then pull them down and then deploy them onto a different system. And we run very, very different server backends, so that there are adjustments that have to be made for the operating environment. Instead, what we can end up doing is, by everything being up in AWS, it just makes being able to share the information, be able to share access to folder structures, to go ahead and look at even when we've gone ahead and processed data and we've come up with a new set of data that can be used. It's just as simple as granting permissions within the AWS interface in order to allow for that use. So it's drastically simplified things and allowed for development to benefit everyone versus one individual group. And that's what we've seen, is that when we look at it, we tend to attack the same problems. We tend to attack them a little bit differently. And then when somebody has a really great innovation, then it takes a couple of years for it to populate across the state. Now, when we look at it and someone has what is, the best solution, it can populate it almost immediately.
And you also mentioned that this was going to help with the university work that you do, and hopefully streamline sharing that data and that code and not having to reinvent the wheel. Have you started any work in that area yet?
We've gone ahead and executed so most of our university agreements are about a year and a half in length. So we've executed our most recent work with UCF about asking them to go ahead and do it for this upcoming cycle. And instead of developing on local servers, which they run everything in Linux, and they go ahead and their operating environment sometimes is a few patches out of date. And when we try to apply it within our version, the kernels are a little bit different. And then we end up having to rewrite subsystems. So when we've gone ahead and put it into place, their access to data has, they also like to write against static databases too, which is fun. When we start going into production, it has to actually have active, databases that are actively being updated. So by providing them access to these systems, what we're seeing so far is that we see that they're developing within the tool. We're seeing some start of that work. We have not yet seen the fruits of the labor of the actual final deliverable. We're hopeful of where we're going to get. Our one caution is we're a little bit worried about someone accidentally leaving on a process overnight and that increasing some of the costs, that we didn't have that financial risk before. So we did talk about that with the university, but when we start working with students, we went ahead and started talking with AWS about how to monitor that, make sure that we're not going to end up with an oops big bill at the end of the day. We're very hopeful of how that's going to end up.
Okay, thank you. Well, I have one last question. I'm not seeing any more additional questions in the chat pod, but I do have one more question for Joseph. Joseph, you mentioned that another state had expressed interest or asked for your code or your information about your pilot project. Can you expand a little bit more on that?
Sure. So Caltrans has expressed interest in utilizing the project, and we had a couple meetings with them, and they're trying to facilitate they're trying to start the process and figuring out kind of what they need and getting it set up. And so they're basically working through those processes. So yeah, no, it's good. And we're willing to help, and it shouldn't be I don't envision it being too challenging. Probably the hardest part of taking the code that we have It's just adjusting the LRS depending on the respective state. But again, I feel that that wouldn't be too big of a task to make that happen. 'Cause It's pretty good process, and then plus it could be used for other use cases as well. So it's good. So yeah, so it's good. So we'll look forward to seeing what comes out of it.
Yeah, definitely.
Yeah.
Thanks for sharing that. Well, we're just about 4 minutes short, so I just wanted to thank all of the presenters, and really it's not just presenting today, it's really their participation throughout the whole project. I think it was really successful, and everybody made some great progress and has a lot of good lessons learned to share. We are documenting each state's journey in a report as well that will be published by TRB at some point in the future when we get that finalized. And I know it was a lot of work and a lot of effort by all the states. And again, just want to thank you for your great efforts and participation and presentations. And also thanks to NOCO for hosting and this webinar and helping us bring it all together. And I hope that everyone was able to take something away from it. And if there's no final questions, I don't know, Anaf or Luana, if there's any closing remarks from your end.
I just want to thank everyone for attending today's webinar. I just want to thank our panelists. We had a great discussion here today. As I mentioned in the beginning, a recorded version of this webinar will be available on NOCO's website. And on behalf of the National Operations Center of Excellence and our presenters, thank you for joining us and have a great day.
Thank you.
Thank you guys very much.
Thank you all. Bye.
Bye.
Thank you.
Thanks, everyone.